Okay, Electrolysis Lab. The idea here is we're going to use electricity to separate hydrogen and water. First step, of course, get my coffee out of the way. Uncap our battery. This is a 6-volt battery intended for lighting. Hopefully it's got enough juice left. I don't know how old this one is. So take our caps off, get our leads ready. I got my red wire here and my black wire here. It really doesn't matter which one I use as long as I know which one's going on which electrode. And for electrodes, hello by the way, I'm going to use a stainless steel screw on one end, and I'm going to use a good old-fashioned iron common nail on the other. And of course, I can't forget my salt. So electricity doesn't actually flow very well. Contrary to popular belief, it doesn't flow all that well through water unless there's something in the water to help carry the electricity, like some salt. So we pour some of that in there, get some free-flowing ions. And I think I dropped my stir stick over here. So here it is. I'm going to give that a little stir. Now, if you add more or if you add less, the reaction will be slightly different. I've noticed in the past that the students that have a little bit less salt in there, it usually turns a little bit more orange, more of what the rust color you would expect. And then if you have extra, you tend to see more of like a greenish, dark solution come out of it. And that's, you know, I'm assuming more of that iron color with the chlorine forming a bond. So now I've got to remember here, I've got my paper. I want to say it was the nail to the positive, but I do have my handy dandy instructions. In fact, I'll put this here so you can pause it and read it if you'd like. All right, so oops, I got to put it the right way here. So there is the top of it. Ooh, it's blurry. And I'll just kind of scroll up a little bit here, and you can kind of see the instructions. All right, so it says teaspoon of salt. Yeah, I didn't really measure. Battery. Oh, come on, where'd I put it? Nail. Attach the alligator clip to the nail head on one end and the positive. I was right. Cool. All right, so go from, you know, just for, usually you take your positive with red just to not get y'all confused with what you'll see in the future or in other aspects of your life. We'll go red, positive, black, negative. And you can see my nail and screw are kind of tipsy, and this one actually came out of the water entirely, so that's not going to create a very good reaction. So we got to get that back down in there. Now these are 9-volt batteries, or this is a 9-volt battery. I've never done it with a 9-volt battery. I don't know if it's going to work. But I can actually already see bubbles starting to form on my screw. When you look at the video, oh yeah, looks like you can see them. See those little bubbles up top there? Let me get a little closer if I can. And you can see a couple of bubbles came to the top. They're still coming to the top. Shaky hands, too much coffee. Okay, so what I think I need to do is probably add a little more salt. So we'll try that first. Although the bubbles are all over that screw, which is exactly what we want. Now, the idea is that those bubbles are hydrogen gas bubbles. So you're taking the water, which is H2O, and the electricity, the electrical current running through, splits the bond between the water and, or between the hydrogen and the oxygen. The hydrogen runs to the stainless steel electrode and comes off as bubbles of gas. The oxygen bonds with the iron and the nail to form rust. Let me pull you over here again. Actually, I can move this a little closer to the camera. I can't move the camera any closer to the drink, but I can move the drink. But I can move the beaker to the camera. Why is it so blurry? Okay, so definitely you can see the bubbles there. A couple of big ones popping off of there. All right, and you can see like the mist looks like down on the bottom. Those are bubbles rushing off of those screws, the threads on the screw. All right, so we've got our reaction going really well. If I can stop the camera from moving. It's perched, by the way, on my Lego Batman lunchbox. Let me give you a look there. Oh, yeah. There he is in all his wonder. Batman would approve, I'm sure, of this experiment. Okay, so we've got our hydrogen. Now, how can I prove to you that you've got the hydrogen going over to the screw and the oxygen coming over here to the nail? Well, first of all, after a while, I should be able to tap the screw and you'll see some gunk come off of there. And not ready yet. So the water is starting to turn color, though. You'll notice it get yellow and yellower, maybe a green later, depending if there's some salt. The other thing I can do, though, is to prove that the hydrogen is coming off of the screw. And the way I can do that is with my handy-dandy grill lighter. This even has the little flexible neck. So now I've got rubber bands holding the screw and the nail, and I really don't want to like make the rubber band go like boing, and then everything flies apart. So I have to carefully, highly scientific here, I'm just going to tip my screw off to the side. Now I don't want it to touch the nail, because if it touches the nail, then the electricity will go directly from one conductor to another and not through the water. Oh, and by the way, you can really see those bubbles going real good now. So all those bubbles are coming up to the surface, and if there's hydrogen there, it'll burn off. So you'll see my flame here is really nice and clear. You guys see that? I actually need to turn it down a little bit. That's a little bit much. There we go. So you see my flame is nice and clean. But if I hold it over that, I should see a little halo of orange come over it. All right, so there's my clean flame again. Put it over the black. Somebody walked by. If they want to come in and watch, they can. No, it's Kraus. Okay. All right, so now I'm going to do that, and you should see the flame. Do you see the halo? I mean, if you can't, I mean, I don't know if you're blind or what, but there's that orange halo over it. Now, if I move it outside, you see it go away. As soon as I put it back in, you get that orange halo again. And that's our proof that we've got hydrogen gas coming off of there. So the hydrogen gas comes off, is the fuel source. Of course, there's extra air, just extra oxygen in the air, and it burns everything else off. You can see our water is getting darker still. If I tap that, you can actually see a little bit. See how quickly it gets darker. Just mixing that stuff in with the water there. Anywho, that's our experiment. But I had to kind of push up the wow factor maybe a little bit. So I said, well, in class we did this with a 9-volt battery, and this is actually a 6-volt battery. It looks impressive because it's a big battery, whatever, it's 6 volts. So I figured, well, what if I took 2? And we had actually talked earlier, just last week actually in class, about wiring a battery in series in order to increase the voltage. And if we ran them in parallel, we would just increase the storage. Well, I'm not interested in increasing the storage. These batteries are pretty big. They've got plenty of storage. What I would be interested in doing is seeing what would happen to our reaction here if I run it up to 12 volts. Is the beaker going to crack and let water spill all over the place? I don't know. We'll just have to see. So, but I'll need an extra cable. A couple extra cables here. And if you're bored with the video, I'm sure you already turned it off, but if you've stuck around, you probably want to see what's going to happen here. So I already have the current being run over here. Now, to go in series, what I'm going to do is I'm going to take the negative from this battery, and I'm going to go to the positive on this battery. And then I'll do the same thing with these other 2 terminals. So I'm just going to cross them. And I'm wondering if I should take this out first. Now, I'm not an electrician. Mr. Armstrong, if he catches wind of this video and something bad happens, I'm sure he'll say, oh, I could have told him not to do that. But I'm just going to try it. We might see a spark on these batteries, and if I do, I'll probably go ahead and stop and try it with the video off. But let's just see what happens. So let's see. No spark. And then I need to get my other one quickly. Where'd I put it? There it is. So I'm going to go, I went from negative to positive, and now I'm going to go from positive to negative, and this will double the voltage running to our screw. I wonder if it's expended or salt here. Well, that was anticlimactic, wasn't it? Whoa, look at that. That color's getting pretty dark in there. Told you it would. So again, that's more of the iron being pulled off. What I'm not seeing any more of are bubbles coming off my screw. So I'm going to see if this caused it by just pulling this back off. So that's disconnected. And sure enough, right away, the bubbles start coming back. So however I wanted to wire that clearly didn't work. Our bubbles are going really well again. Okay, so let me think on this for a second. My mother says that's dangerous thinking. Yeah, I don't know. Couldn't tell you. If I run positive to positive, that wouldn't be in series, it'd be in parallel. So I would just increase my storage. Well, we can test that. So if I run this over negative to negative, should increase my storage, and the reaction should continue, and it does. It can just go on longer now. So somewhere in there, I must have shorted it with the whole series thing, or it just doesn't like working with 12 volts. Maybe it needs 9 or 6 or some lower number of voltage to work. I'll have to look into it. Maybe Armstrong will see this and tell me. We'll see. Look at it go. Woo-wee. That's all for now.